Once again, learners, in this video we'll be focusing on momentum. This is a last year June examination paper. So we are told that trolley A of mass of 7.2 kgs moves in a straight line with an initial velocity of 0.4 in a straight line on a horizontal floor. It collides with a stationary trolley B, meaning that V initial is equals to a 0. Trolley B of mass of, we are given the mass of trolley B. After collision, the trolley is locked together. This is important. After collision, the trolleys lock together. It means that they now move with the same velocity after collision. And they move to the right. Remember, the direction is important because we're dealing with vectors. Ignore any effects, any frictional effects. So let's quickly jump to question 1. And question 1 says, it states the principle of conservation of linear momentum. We know that it states that in an isolated system or closed system, the total linear momentum is conserved or it remains the same. You get your 2 marks. We go to 4.2. 4.2, they said 4.2.1. Calculate the magnitude of the velocity of trolleys immediately after collision. Okay, so we go to our formula. Say momentum before, sum of momentum before is equals to sum of momentum after collision. What happens before? We see our trolleys separate. So you are now going to do a momentum for trolley A, the mass for trolley A, and its velocity. Remember, before collision we have initial plus mass for trolley B and its initial velocity equals to, after collision they are now locked together. They are locked together after collision, so you write your equation like this: m1 plus m2. Then you have V final. Remember, after collision you have V final. Now it's a matter of substitution. The mass for trolley A, remember this is trolley A and that is trolley B. So the mass for trolley A is 7.2. And the initial velocity for trolley A is 0.4. They say the trolley B initially trolley B was stationary. A stationary trolley B. So if this trolley B is stationary, that means this velocity is 0. Anything multiplied by 0 becomes 0. So we don't have that part. This part goes off. So we proceed. Then we go to the other side. The mass for trolley A, it is 7.2 plus. The mass for trolley B, it's 5.3 V final. Then when you get in here, we punch that other side, 7.2 plus 5.3. On this side, I got 12.5 V final. Then on this other side, we have 7.2 multiplied by 0.4. On this side, I got 2.88. Then we divide by 12.5 both sides. Divide by 12.5 both sides. This cancels that. We have V final, which is equals to, so we have divide by 12.5. Therefore, our V final is 0.23 meters per second. We say to the right. To the right. On 4.2. On 4.2. On 4.2. 4.2.2. It says calculate the net force exerted by trolley A on trolley B. By trolley A on trolley B during the collision. If the collision lasts for, we are also given time. Can you see now they are now introducing forces on Newton's laws. So we know that now we are now dealing with an impulse. So the only formula that includes the forces is impulse. We know that formula is F net multiplied by delta T equals to change in momentum. Now it's the force exerted by A on B. Exerted by A on B. So we will use trolley B. So let's start by finding change in momentum of trolley B. So I'll use that space up there. We have change in momentum, which is M, V final minus V initial. Then the mass for trolley B is 5,3. V final, remember they were locked together after collision and they were moving with the same speed, with the same velocity, which is 0,23. So we have 0,23 minus V initial. Trolley B was stationary before collision, so we put a 0 in there, then we punched. We have 5,3 multiplied by 0.23. Then we got 1,219 kg meters per second. Then we take that and substitute it to the equation. So we have a change in momentum, which is 1,219. Then here we are looking for the force F net. We do have the time was given, it's 0.02. Then we divide by 0.02 both sides, and therefore the force will be, when you see 1,219 divided by 0.02, we got a 60.95 newtons. We say to the right, that is your force.